welcome to Parallel and Series Parallel Diode Circuit. Okay, so let's start with example number 1. Compute for I1, I2, and V out. Okay, so ano equation natin dito? Starting from the supply. So take note that this is a node na, no? Yan. Ibig sabihin, positive 5, ang nakakabit dito is positive ng battery or positive ng DC supply. So starting with the positive 5, ano equation natin? Hello, class.
Yes, ma'am.
Positive 5.
Okay, positive 5. Di naman kayo masyado magkakamali dito, di ba? Kundi plus, minus. O, yan. Ayan. And then, so sabi, di ba, sa electrical circuit, ano yung constant pag parallel yung circuits? The current or voltage? What is constant kapag parallel circuits?
Current.
No.
Voltage.
Voltage, okay? So, para
Voltage.
voltage is constant in a parallel circuit. Pag sa ano naman, series, current naman yung constant, okay? Okay, tandaan niyo yan na. That's important principles yun. Okay. So therefore, since they are both silicon, and what is the voltage drop across silicon diode?
0.7.
Okay, 0.7. Pareho naman sila ng orientation, di ba?
Yes.
So, by the way, what do you think are the, since they're both same direction, okay, same direction siya, ano yung state ng diode? D1 and D2 are both, ano? Anong bias niya?
Forward.
Okay. D1 and D2 are
Forward
both.
po.
Yeah. Okay ka lang? Okay. Forward bias. So, pag forward bias, what is the voltage drop across diode? Silicon diode.
Minus 0.7.
0.7. Ilang 0.7?
Dalawa, ma'am.
Ilan?
Dalawa po.
So, maging 1.4 siya. Tama ba?
Yes po.
Ay, yung iba.
Isa lang
Hindi
po.
naman lahat sumasagot eh. Ano? 1.4?
Yes, ma'am.
Minus 0.7.
0.7.
Isa lang. Kasi nga, they are connected in parallel. Diba? Oo, parallel sila. Kaya, isang 0.7 lang. Okay? So, ang assumption is that the diode 1 and diode 2 are identical. Ayan, pareha sila ng property. Okay? So, they both exceed 0.7. Okay? So, since parallel siya, so 0.7 lang. So, isang 0.7 lang. Since the diodes are connected in parallel. Okay. So, summation voltage is equal to 0. Anong sunod na voltage to? So, voltage drop across R1. And what is the voltage drop across R1? Ano yung Ohm's law? V is equal to?
IR.
Times IR. Okay, minus IR1, then? Okay, ang galing nyo na, ha? O 0. So take note that R1 and R2 are connected in? How are R1 and R2 connected? Are they connected in series or in parallel?
Series.
So take note that R1 and R2 are connected in series. So therefore, ano yung constant kapag series?
Current.
So therefore, since the I that is flowing through R1 is the same current that is flowing through R2, so we can factor out the current. Tama ba?
Yes.
Okay. So therefore, we now have a formula for I. Okay, this is actually the I total kasi mamaya pinapakuha sa atin yung what is the value of I1 and I2. What is the value of current that is flowing through each diode? Okay, so I total would be equal to, so you have, anong formula natin? So, isayin pa ba natin? So, 5 minus 0.7, so 4.3.
4.3.
Okay? Yan. Is equal to I
R1.
Times
na pala
2
to.
kiloohms.
Sorry.
Yes, boss.
So, okay. So, this should have been positive. Kasi nilabas natin negative, di ba? So, nilabas natin negative. So, minus I times R1 plus R2. So, therefore, I is equal to, so your I total would be equal to 4.3. So, divided by R1 plus R2. So, 2K.
2
Na, no? Tama?
kiloohms. Yes po.
Okay. 2 kiloohms. Anong sagot?
2.15 po milliampere.
Times 10 raised to negative.
So, I total is equal to 2.15
2.15, ma'am.
milliampere.
Milliampere.
Or take note of the units, ha? Marami nagkakamali sa units, ha? Did you do your homework? Yan, scientific notation, okay? Engineering notations, yan. You have to review. Okay, so our total is 2.15 milliamperes. Tama yung I total na yun. Stop niyo muna pag hindi kayo sasagot, medyo maingay. Okay, the I total is actually this one. The current that is flowing through R1 and R2. Yan. So, okay. Kakaroon ng divergence. Ayan. Actually, that is also the I total that is flowing through from positive 5. So, nangyari, the I total, yan, this is the same I total here. Ayan, I total pa rin to. Tama ba? Tama? Mali. Parang kalsada, di ba? Ayan. Yun. Ayan. Ito yung kotse. Ayan. 100 lang. Then, you have to make a choice whether dito o dito ka dadaan. Okay. Pero pagdating sa dulo, magsasama pa rin yung mga, mag-merge pa rin yung mga cars. Okay. Ito yun. Okay. So, the same I total here, same I total here. Yun din yung I total na nagpo-flow through the R2. Tama ba? Okay. It's the same I total here. Ayan. I total pa rin siya. Okay, and this I total, ano nangyayari kay I total? The I total is being branched out. Oh, ayan. Some current flows through diode 1 and some current flows through diode 2. If that is the logic, so what do you think is the value of I1? Ano assumption natin dito para makuha natin I1 and I2? Gusto sumagot, pwedeng on mic. Ano assumption?
I-assume po na equal na current ang dadaloy sa kanilang dalawa.
Okay, thank you, Felix. Okay, so assumption is that the I1 is equal to I2. Okay, and also since I1 is equal to I2, so take note that the I total branches out between I1 and I2. Dalawang branch lang siya, di ba? And the assumption also is that I1 is equal to I2. So therefore, we can say that if that is so, I total could either be equal to 2I1 or 2I2. Tama ba?
Yes, ma'am.
So therefore, I1 is equal to I2 is equal to half of I total. I total. So if that is half of I total, so we have, anong value natin? 2.15 milliampere divided by 2 is equal to 1.08. Tama ba?
Yes, ma'am. 08. 1.08.
1.08 or 1.075 milliampere. Okay, so you have 1.08 milliampere. Okay, and what is V out? V out, saan ba natin measure ang V out? Based sa, can you see my pointer, mouse pointer?
Yes po.
Okay.
Yes,
So,
yes.
saan tayo magme-measure ng V out? Based on the circuit, okay? So, this is dito yung V out. Kung meron tayong VOM, yung positive, itatap natin dito. And the negative will be top here. So, basically, we are measuring the voltage across what device? Ano yan? Across ano? Ano mini-measure natin? Voltage across diode R1, R2.
R2.
Okay,
R2
so
po.
we are actually, yan. We are actually measuring the voltage across R2 kasi as you can see, dito ang positive, dito yung negative. That is the voltage across R2, di ba? And what is, based on Ohm's law, what is voltage equal to?
Negative IR.
IR. Voltage is equal to IR. And in this case, IR2. V out is equal to IR2. So we have current of, anong current ang gagamitin natin? The 2.15 or the 1.08 milliampere?
1.08.
Bakit 1.08?
2.15.
2.15.
2.15.
2.15 po.
Oo, kasi as you can see, nag-merge naman. Okay? Sa total, nag-branch out sa D1, D2. Pero pagdating dito, nag-merge ulit. Okay? So, 2.15 milliampere times 1K. 1K. So, we have V out therefore is equal to 2.15 volts. Question?
Ako, ma'am.
Yes.
Hindi po ba siya i-multiply as 2.15 times 1,000?
1K is 1,000. But you have 2.15 milli. And what is milli? Times 10 to the negative 3.
Okay.
Yes, ma'am.
Opo.
Oo, kaya wag yung marami nagkakamali dito class sa mga dinidisregard dilemma. Milli, kilo, malaking factor 'yon, di ba? O imagine, milli to micro, that's a factor of 1,000. Magkaibang ano na yun. Yun. Kilo, yan, mega, yan. You have to be familiar with the scientific notation, ha? Times 10 to the negative 3 milli. Sunod nun, times 10 to the negative 6 micro, times 10 to the negative 9 nano, tapos times 10 to the negative 12 pico. Yan, times 10 to the 3, times 10 to the positive 3 kilo, times 10 to the positive 6 mega, times 10 to the 9. Ano yung times 10 to the 9? Giga. Okay. Then, times 10 to the 12 tera. O, yan. Parang ano lang, frequency ng cellphone, di ba? Yan.
Ma'am, excuse me po.
Yes.
Yung pong assignment po, naka-turn in naman po siya doon sa assignments. Na part.
Sige, okay. Kasi nakita ko na yung ano. Okay.
Parang dinalawa ko po, ma'am. Hindi ako sure eh.
Nagdalawa ka lang. Nagdalawa. Sige, okay. O, nandun yun. Kung nandun yun, nandun yun.
Sige po, ma'am. And clarification po, ma'am. I remember po from voltage law, di ba po, voltage is equals to IR, where ang unit po ng current natin is palaging ampere, and ang unit po ng ating resistance ay ohms. Tama po ba?
Oo.
So, okay. So, yun nga po. So, yung 215 milliampere, parang simple math. Ilalabas ko lang yung decimal point. Magiging 000 point, parang ganon. Para maging ampere.
Ano?
Parang ganon.
Para lang gumamit ng calculator kasi kung lagi mo siyang i-convert into absolute value. Paano kung micro to, ilang zero yung i-input mo?
Marami-rami rin, ma'am.
Paano kung nano? O kaya pico? Tsaka malamang magkamali ka na yan sa dami ng zero. Kasi ang display lang ng LCD, mga ilan lang yon. Baka naligaw ka na sa dami ng in-input mong zero, hindi pa rin tapos yung pag-input mo. Pag-aralan yung paggamit ng calculator, ha? Paano in-input yung mga milli.
Yes, ma'am.
Magkakamali kayo. Marami nagkakamali sa ganyan, class. Tama na sana. Pero mali pa rin. Kasi magkaiba yung, alam mo, 2.15 amperes sa 2.15 milliampere, malaking pagkakaiba yun, di ba? O positive to negative, malaking pagkakaiba yun. Kung isa kaliwa, isa kanan, di ba? Yan. Hindi pwedeng magkamali sa mga computations, kahit nga sa sign, di ba? Hindi pwedeng malito. Hindi pwedeng malito kung mahal mo ba o hindi. O yan, dapat alam mo, sigurado ka, di ba?
Yun.
Hugot.
Opo, Ole. Ay,
Oo, na wala yung sigurado kung ano, kung siya ba o hindi. O yan, kung sigurado ka ba o ano. Dapat laging yung sinisigurado yan. Okay? Question.
none po, ma'am. Thank you po.
Ako po, ma'am, may question po.
Ano?
Doon po sa assignment.
Assignment ka rin.
Kung yung final answer ko po is 2.15 times 10 raised to negative 3 tapos naka-amperes po, tama pa rin po?
Tama pa rin yun.
Okay po. Thank you po.
Pero mas maganda kung you get accustomed with yung mga ganito notation. About times 10 to the negative 3 milli. Small m iba yung small m sa big M. Big M is mega. Tama ba?
Opo.
Okay?
Po.
Ayan.
Thank
Small
you po.
m. Pag big M yan, mega. Iba yun. Okay? Mega is times 10 to the 6. Okay? Yan. Mga engineering kasi exact science, di ba? Yan, hindi pwede dito yung pakiramdam lang, hindi pwede, ano. Kahit yung pakiramdam lang, kailangan meron kang pinagbabasihan na definite, parang definite na science or exact computation. Bakit yun ang palagay mo, yung conclusion mo, how did you arrive to such conclusion? Okay? So you have to support your pakiramdam. Ayan. Okay, ayan. Okay na? Shall we proceed?
Yes, ma'am.
Yes, ma'am.
Okay. Ayan. Ano pinagkaiba niya sa... Ayan. Meron na tayo. Meron tayong third diode. Take note, this one is germanium. So when you say germanium, so the voltage drop across germanium is?
0.3.
Okay, 0.3 volts. Okay. Kung, ayan, okay. So let's proceed. Okay, so alamin muna natin yung state ni D1 and D2. Anong state ng D1 and D2?
Forward.
Okay, forward.
Forward.
Okay. How about D3?
Reverse.
Reverse, ma'am.
Okay.
Reverse po.
Parang hindi sigurado Ayan. Okay, so since reverse siya, okay, i-duplicate natin para hindi tayo mawala. Okay, duplicate slide. Ayan. Since reverse siya, so anong gagawin natin dito? So the equivalent of this is an open circuit.
Open circuit.
Open circuit siya. Ayan. Okay. So ibig sabihin, pag open circuit, may current pa ba na magpo-flow dyan? Would there be any current flowing through? Wala na. Cut off na siya dyan, di ba? So, mayroon dyan is that, halimbawa, we have a VOM dito, nakakabit dito, sa positive dito, negative dito. So, ano kaya mangyari? So, what will be the voltage? So, mangyari, ang loop natin is from positive 5 to V out. But the V out is definitely not equal to R2 and the voltage across germanium. Kasi open na siya. Pero tingnan natin what would be the voltage here to here, no? Parang okay. So let's start from the positive 5. Anong equation natin?
Positive 5.
Okay, positive 5 volts. Then
Plus 0.7.
Minus 0.7.
7 and
Minus IR.
Minus
R1. R1 and
Plus R2.
wala na. Zero na. Kasi wala na cut off.
Zero na
is being cut off, di ba? Ayan. So, parang mag-loop din tayo from positive 5 to V out. Okay? The V out
Ma'am,
here,
bakit hindi po naisama yung IR2?
again,
Bakit hindi po naisama yung IR2?
ay cut dito, oh. Cut.
Kahit before component po siya makat.
Oh, wala na. Wala nang current dyan. Wala nang current dyan. Okay. Yan. Bari, IR1 minus V out. Nga naman, no? Bitin. Minus V out is equal to 0. Okay. O, sige. Papaisip tuloy ako.
Ma'am,
Teka
question, ma'am.
Tama, I get your point. Okay, balik tayo. IR1, IR2. Okay, but then your V out, tama no? But your V out, hypothetically is equal to IR2.
Oh, bakit
Yan.
paano may different yun?
Di ba nakakonect naman sa VD3? Pero, ang current ka natin is, since cut-off siya, yung current natin, dahil open siya, Zero. Stick pa rin tayo dyan. 0. Okay. So, if this is 0, okay,
Hindi, sa sinubukan mo lang. Dapat
may V out ka pa rin dito.
sa computer.
Okay. Pero ang V out mo is not, hindi na siya base dito kasi this is equal to 0. At lalong hindi rin siya base sa VD3 dahil VD3 mo is reverse bias. But you still have V out. Okay? Ba't tayo magkakaroon ng V out? It's because of this equation. Okay? So, this is equal to 0 now. 0 ko na siya. Okay? I'll just remove this. So, your V out now is equal to
Gawa ka na nga. Baka pwede kong
4.3.
para ililipat mo na sa damit.
4.3 volts.
Gumawa ka
Okay.
na nga.
So, meron kang output voltage dyan equal to 4.3. Pero wala tayong current because this one is open. Open siya. Open yung ating circuit. So, pwede magkaroon kayong voltage with 0 ampere. So, you have maximum voltage. 4.3.
Ma'am, question, ma'am.
Yes.
Ma'am, pag hindi po siya open circuit, sa ground po nalabas po. Pero pagka open circuit, sa Vout po nalabas. Ganun po ba, ma'am? Sumasama sa formula yung Vout. Kasi dun sa nauna natin, ma'am, hindi kasama yung Vout, di po ba?
Hindi na yung tanong. Pakiulit, please.
Doon po kayo sa una, ma'am, hindi po siya nasama sa yung Vout sa ano po natin, sa equation natin, dun sa unang sample kanina. Pero pagka ganito po, open circuit.
Ito yung ngayon lang.
Opo, ma'am, opo, ma'am.
Ayan, yung V out mo is actually equal to, same lang naman to eh. V out is equal to IR2. In this case, we have current kasi forward bias, di ba? You have a continuous circuit. Wala namang open circuit dito eh. Tama ba? Yan. So, ang dinagdag lang natin dito is yung diode. Nagdagdag tayo ng diode. Okay, so let's check. Compare it with example number 2. Ito yung dinagdag natin, di ba? The VD3. But this time, the diode 3 is connected in, ano siya? Reverse bias na ngayon yung D3 natin. Kaya, ang effect niyan is cut off. So, kung mag-measure tayo ng VOM dyan. Okay, so you have VOM here. And then, yung positive, okay, so positive to, isa negative. Okay. Saan ka lang ba? Ayan, saan natin lalagay yung positive dito? Pardon my drawing. Okay, so positive dyan. Yan, sa ano yan. Then, ayan. Ayan. Ganyan na mayayari dyan. Okay? May measure ka ang V out 4.3. Bakit? Kasi wala ka namang voltage drop across R1. But wala kang voltage drop across R1 because your current is 0. Bakit 0 si current? Dahil nga, open yung circuit mo. Diba? Kumbaga, hindi makatawid yung current kasi putol yung tulay. Walang flow ng current dahil putol yung path mo. But then you have voltage. Meron ka pa ring voltage which is equal to 4.3 volts. Hello?
Yes, ma'am. Yes, ma'am po.
Yes po.
Okay. Pag nag-actual tayo, makikita niyo yan. Meron ka talagang output, pero wala kang current. Okay, so example number 3, compute for I1, I2, and V out. So same, ano naman to? Ayan. Binaligtad ko naman yung D3.
Forward bias na po lahat.
Ayan. Yan. Forward bias na lahat. Kaya bago kayo mag-compute, check nyo muna kung ang D1, kung mga diodes nyo ay kung anong state ng diode. So, they're all forward bias. Okay? Malinaw ba o nalilito? Sige lang.
Yes, ma'am. Tuloy lang po.
Tuloy lang.
Malinaw po.
Yan. Undi-undi lang natin. Ayan. Nakakalito naman talaga pag umpisa, di ba? Ayan. Paano naman tayo equation naman yan? So, lahat forward bias. So, meaning, may voltage drop ka sa germanium. Okay. Meron ka sa silicon. Ayan. Meron tayong, anong meron? Meron tayong current. Ayan. May current tayo. Ayan. Kasi walang putol na linya. Okay. Sige. Equation.
Positive side.
5
Positive side.
minus 0.7.
Less 0.7.
7 pa.
Minus IR.
Minus
Minus
IR.
IR.
Minus
1.
2
Okay.
R1.
IR.
Okay.
Minus
Minus
2.
IR.
IR2.
IR2. And,
Minus 0.3.
okay,
0.3 volts.
0.3. Okay. Is equal to 0.
0.
Then, ano na sunod? Current, no? Current. Okay. So, shortcut ko na, no? 5 minus 0.7 minus 0.3 is equal to
4.
3.
okay, 4 volts divided by R1
2.
plus R2.
2 kilo ohms.
Okay, 2 kilo ohm. Okay. 2 kilo ohm. So we have 4 divided by 2, so you have 2 milliampere.
Ampere.
What is now your V out? Okay. So your V out, okay, so we're going to take note that V out is taken across 1K, IR2, and
IR.
IR3.
ano, R2 and germanium, no? Yan. Tama ba? So, kung mag-measure tayo dyan, okay, yan, ba, meron kang BOM, yan, kopyahin na lang kayo natin na una. Saan ka na ba? Yan. Meron tayong BOM. Ayan. So, itatap niya yung, tap niya isa dyan. Then, may BOM na kayo. Ito naman sa isa, dito sa ground. Nakabili na kayo ng BOM? O,
No, ma'am.
nakahiram na kayo?
No, ma'am.
After ng unit exam natin, mag-experiment na tayo, ha? Ayan.
Yes.
Base here. Ayan, base here. Anong masasabi nyo? Ang V out natin is taken across
R2 po.
R2
total,
and
no?
D3. Okay. So, R2 and D3. Kanina, across R2 lang, di ba? Kasi isa lang yung members mo dito, 1K. Dito naman, yan. Yun, putol siya. Wala kang current na measure. So, walang voltage drop across resistors. Okay? So, yung V out mo is 5 volts minus the voltage drop across diode. Yun lang na measure mo, which is 4.3. Yan. And ano pa? Okay, yan. So, V out. Ngayon, anong formula for V out? Okay, so let's have a loop. Loop 2. Loop 2 tayo. Okay, starting from positive V out to... Yan, bakit ang payat ng ano na to? Okay, yan. Ayan, loop 2. Yan, okay? So, let's have the equation for loop 2 starting from, kasi ito positive eh. Ang assumption dyan is that this is positive V out. Yung assignment ng V out yan is positive. Yung ground, it's always negative. Ang assignment dito is negative. Bakit ganun? Kasi pag magtatap ka ng VOM, yung positive, lagi mo nilalagay dito. Yan, yung negative, laging dito. Okay? Kaya ang assumption natin dito is like, this is positive V out. But it doesn't mean that the answer is always positive. Yun lang yung assumption mo. Tama ba? O sige, wag po na natin isipin yung mga bagay-bagay. Nasaan na tayo? Huwag mo na natin isipin yung mga bagay-bagay. Let's step by step. Okay, so this time naman, mag-start tayo sa positive V out. Ano equation natin? Okay, summation of voltage at loop 2. Loop 2 naman tayo. Ano naman equation natin from V out? Start tayo sa V out. Kanina, nag-start tayo sa positive pa. Dito naman, start tayo sa V out. Okay? Anong sign nitong V out?
Positive.
Positive V out. Then, same direction of current and same direction of the loop. Anong assumption
Minus
natin?
IR.
Minus IR.
IR.
Okay, minus IR2. Okay, minus IR2. And,
Minus
ayan.
Plus
0.2.
Pumasok sa positive, lumabas sa negative ng diode. So, therefore,
Minus point.
minus 0.3.
Saya magaling. Okay. So, meron na tayong value ng I. Ang hahanapin na lang natin is the V out. Tama ba? So, V out is equal to,
Yes.
okay, pag nilipat natin itong negative IR2 and negative 0.3 sa kabila, it becomes,
Positive.
okay, so it becomes positive. Ayan. Ayan. So, we have V out is equal to, ano ba yung current natin? 2 milliampere times 1
Times
1 kilo ohm.
1 kilo.
Kilo ohm.
Okay, 1K and plus 0.3.
Plus
Plus
0.3.
Okay.
20 volt.
Ang sagot.
2.3.
2.3
Okay, so you have
2.3
2.3.
ampere.
volts.
Ay, volts.
2 milliampere times 1K is 2 volts plus 0.3. So you have 2.3 volts. Okay? Tama? Question.
Yes, ma'am.
Feeling ko naman tama siya eh. Sige, okay? Tanong. Nalilito pa ba? Subukan yung subukan yung mag-solve. Ayan. Solve na natin siya. Subukan yung mag-solve ng sarili nyo. At least may guide kayo kung tama ba o hindi. Diba? ba? I-replicate ko lang kung ginagawa natin pag-solve para maging familiar kayo paano siya sinosolve. Okay?
Yes, ma'am. Ma'am,
Yes.
medyo, question po, ma'am, medyo
Yes,
ito lang sa science, paano nagiging negative, nagiging positive.
Sa-
I know po na yung base ng diode is positive. Tapos po yung
Kung saan lumabas?
kung saan po lumabas.
Oo,
So,
kaya minus to minus 0.3.
okay po. Yung IR2 po.
Pag same direction yung current and the loop.
Okay. Okay.
This is the direction of the loop. This is the direction of the loop. This is the direction of the loop.
Okay. Noted po,
Same
ma'am.
direction, mind.
Doon pala siya galing. Okay.
Pag otherwise, pag reverse yung direction ng loop and current, kagaya ng last week, plus yun. Yan.
Okay po.
Ako, dapat tandaan nyo yan kasi hindi yung common errors, yung direction of the loop and the current. So, sa pag-formulate nila, yan, nagkakabalik-baliktad yung minus plus. So, malaking bagay yon, ha? Kaya kailangan familiar talaga kayo sa direction. Sa battery supply, kung saan lumabas, yun ang
Yung sign.
lalabas sa positive 5. O, dito sa diode, lumabas sa negative, kaya minus 0.7. Okay? Question?
Ma'am, yung 2 milliamp times 1 kilo ohms po yun, di ba?
Yeah, opo.
Plus 0.3. Nagiging ano siya, ma'am? Maraming zero. Saglit lang po.
Hindi, milliamperes times 10 to the negative 3. Pipindutin mo yon times 10 to the negative 3. 1K is times 10 to the positive 3. Pipindutin mo rin yun, di ba? 10 to the x or exp sa ibang calcu. Nandyan pa ba kayo? Hello?
Hello po, ma'am.
Yes, ma'am.
Yes po.
Shall we proceed?
Sige po.
Ma'am.
Okay po.
Okay. Okay. So, example number 4. Ayan, compute for I1, I2, and V out. Ayan. So, binaliktad na natin. Ito naman ngayon dito naman ngayon yung parallel combination ni SI, silicon. Ayan. Okay. So, paano ba yan? Yan siya, no? Ang unang gagawin natin ay determine the state of diode. So, D1. Ano si D1?
Forward.
Okay, forward. Whereas D1, parang D1, D2 and D3 na dapat. D2 and D3. Paano si D2?
Reverse.
Forward.
Lamang kung forward or reverse. Review.
Forward.
Forward,
Positive to positive.
positive or negative to negative. Okay? Positive to positive, negative to negative. Whereas reverse, positive to
Negative.
negative. Ano ba to? Ano ba tong yung parallel lines na to?
Negative.
Okay.
Negative to negative.
Negative. Okay? Negative connected to the positive. This is positive. Okay? Positive. This is
Reverse.
negative.
Reverse.
Okay? So therefore, this is reverse. Okay?
Yan.
Dapat maliwanag sa atin yan, ha? Okay. D1 is forward because this is, itong side na to, this is, ano itong side na to? Side, okay? Positive connected to the positive. Okay? Kaya forward. So they're all, okay. So, ano mangyayari? So, open siya. Takpan na lang natin, no? Insert. Ayan. Open. Open pala siya. Okay, field. Oh. Na. Over. Okay. Ina ba yun? Yan, okay. So, galing natin na ano. 9. Yeah. Ayan. So, na siya ngayon. Tinakpan ko na lang. Ayan, thank you. Ayan, so open si D1 and si D2. Ayan. But then, meron pa rin tayong V out. Ayan, kahit na open sila. Okay. Anong equation natin? Starting from... Yeah. So, mangyari dyan is from positive 5 to V out tayo. Ganun mangyari, no? Positive 5 to V out. So, we have... Anong equation?
Positive 5.
Okay, positive 5.
Minus 0.7.
With 7.
0.7 volts.
Minus.
Minus
I
Is equal to... may V out pa pala, sorry. Minus V out.
equal to 0.
Kasi assumption natin, this is positive V out, di ba?
Yes.
This is positive V out. Yan. Kaya lang, again, since open circuit siya, may current ba tayo?
Wala na.
0.
Okay, zero na, di ba? Ayan. Kaya ano maging V out natin?
5.
Oh,
Ay,
we
4.3. 4.3.
4.3.
Zero. Yan.
3.
Tinanggalan na natin, okay? Kasi zero siya. So, your V out is equal to 4.3.
4.3 volt.
Okay? So, we have... ito naman. Paano naman to? Sagot ba natin? Question pala, question. Wala naman. Clear?
Yes, ma'am.
Dali lang ba? Okay.
Yes, ma'am.
Sige. Ayan, dito. Jump tayo sa number 6. Okay? Number 6. So, we have 2 diodes in parallel, pero yung isa germanium, isa silicon. Ano kaya mangyayari?
Yung mas mataas yung ano ma'am.
Parehong mag-on?
Mag-off
Walang
po.
mag-on? Parehong
Parehas
on,
mag-on,
parehong off? Germanium lang ang active or silicon lang active?
GE ma'am yung magiging active po.
Sabi nun?
Ako po ma'am, si Vince po.
Vince. Bakit?
Ma'am, mas mababa po kasi yung voltage ni GE. Kaya mas dun po unang papasok yung current.
Aha. Iba, nagsabing parehong on. Nawala na. Wala namang right or wrong dito. Felix.
Feeling ko ma'am pareha sila mag-on kasi open circuit closed circuit naman siya eh. Pareha silang dadaanan ng current. Lalabas din naman po sila sa isang point eh. So I think ang consideration po natin dyan is parang i-average ko siya. Parang gano'n.
Iba. May nagsabing walang mag-on eh. Okay? So, dalawa lang? Okay. So, may tumataas ng kamay. Flor de Liza, Morga.
Ma'am, sa tingin ko po yung sa SI kasi mas mataas yung ano niya po.
Okay. Silicon naman. Yung walang mag-on, may sumagot ba? Last na pala to eh. Sige. Okay, last na to, no? Ayan. So, we'll go with the answer of Vincent. Okay. Kasi germanium is 0.3, silicon is 0.7. Kagaya ng explanation niya, the silicon will never have the chance to turn on theoretically. Kasi this germanium is 0.3. Ayan, 0.3 lang siya, di ba? Whereas the silicon is 0.7. Mauuna talaga siyang mag-on. Siyempre, kung meron mo ng kalsadang dadaanan, bakit ka pa magta-try na i-build, paanda rin to, di ba? Or i-build tong kalsadang to ng silicon. Kung may madadaanan ka ng germanium na diode, tama? Okay. So theoretically, the silicon diode will never turn on. Okay? Will never turn on. If that is the case, okay? If that is the case, so anong gagawin natin? Okay? If that is the case, then anong mayayari? D1, okay? The germanium is, conducting. Whereas, D2, silicon, yan? Ayan, off siya lagi or open circuit. Okay? It will never have the chance to fire. Yan, hindi na siya magpa-fire talaga. Kasi 0.7 siya, di ba? Whereas germanium is only 0.3. Tama ba? Question?
So, ibig sabihin, ma'am, kung ano yung mas mataas, yun lang yung i-acknowledge natin.
Hindi, mas mababa nga sa germanium eh. 0.3 nga to, di ba? Kuya. Kasi si silicon is 0.5.
0.7, ma'am?
0.7. Sorry. 0.7. Silicon is 0.7, germanium is 0.3. So, graphically, okay, so graphically, mag-graph tayo dyan. Ayan. Okay. Graph tayo. Ayan. This is the voltage. Okay. So, let's say this is the 0.3 mark and this is the 0.7 mark. Okay. Tama ba? Okay. Yan, this is 0.3. 0.3 volts. And this one is 0.7. Yan. Ayan. Ayan. Pagka mag-graph tayo, saan kaya? Ano na lang? Ayan. So, from 0, ayan. And then, hypothetically, mag-shoot up agad si germanium. Okay? This is the ideal graph. Okay? Ideal graph yan, ha? Yan. Pero sa, ano yan, exponential dapat to. Okay? So, this is a graph for silicon. Okay? This is the ideal graph for silicon diode. Okay? This is the graph for germanium diode. So, mauna talaga mag-fire up si germanium. Kaya wala na opportunity si silicon na mag-on. Yan. Kasi most of the current will flow through germanium. Yan. Kaya wala nang opportunity mag-on si silicon. Tama?
Yes, ma'am. Yes po.
Okay. So, what's the theory behind that? Okay, bakit pinagon? Although, pareho silang forward bias, di ba? Pareho naman talaga silang forward bias, okay?
Yes.
But then, in case na dissimilar diode sila, one is germanium, one is silicon, the one with the lower voltage fire up, yun yung mag-activate. Okay?
Yes, ma'am.
So, if that is so ano na mangyayari dyan? So, from series parallel, naging circuit na lang to?
Series.
Series na lang siya. Oh. Yan. Anong equation natin?
Plus 5. Positive 5.
Positive 5.
Positive 5.
Positive 5.
Positive 5 minus
Minus
0.3
0.03.
Okay, 0.3.
Minus
minus
IR
1.
IR.
IR
1.
1. And, next. Yan. Minus.
Minus
IR2.
IR2.
We have two resistors, no? Kaya dapat IR1, IR2 din. Nasa ground na tayo. Okay? So take note that our assumption current is that it flows from, and then flow yung current natin from positive to negative. So this is positive from,
Negative.
yan. Ito, ganyan ang direction ng current natin. Okay? From positive to negative. So, naging series circuit na lang. Dahil hindi na mag-on si silicon diode kahit na forward bias siya. Okay, it will never have the opportunity to turn on. So therefore, what is now your current equal to? 5 minus 0.3 is 4.7
4.7.
by R1 plus R2 to 2K. Shortcut na, no? Kasi, bakit naging 2K yan? Bakit
Negative sa negative.
Okay, pinactor out natin si? Bakit?
CIR.
Okay, pinactor out natin si current because in a series circuit, what is constant?
Current.
Okay. In a series circuit, current is constant, so that's why we factor out the current here. So it becomes I is equal to R1 plus R2. So I is equal to 4.7 divided by 2K is equal to
2.35 milliampere.
Okay? And the V out is taken across. Saan natin kukuha? Saan na ba yung VOM natin? Mag-insert tayo ng VOM. Group na nga kita. Okay? Saan ka na? Okay? Mag-measure ka ng V out. Ayan, may VOF tayo. Ayan. So again, positive. I hope na-imagine nyo na itong lecture natin. Na-imagine nyo ba? Ayan. Ganyan nga, no? May probe ka. Yan. Positive, lalagay mo dito. Yung negative, lalagay mo dyan. Okay, ano kaya ma-measure natin dyan? V out is equal to? V out is taken across? Ano ba to?
V out is equal to R2.
R2. Therefore, by Ohm's law, voltage is equal to? What is Ohm's law?
IR.
IR.
R2. Okay.
IR2.
Yan. R2 to eh. Lagi nawawala eh, no? Ayan. 1 and IR2. Okay? We have a current of 2.35 times
1
okay.
times
12.
1 kilo ohm.
Okay. 1K. Anong sagot? Yeah.
2.35.
2.35. 35.
Ayan, 2.35 volts. Okay? Question. Ayan. Ipopost ko tong example number. Ano ba yung hindi ko sinagutan? Example number 6. Post ko to sa assignment. Then that will be your seat work for tonight. Okay?
Yes, ma'am.
Okay. So, wait nyo na lang yung notification kung kailan ko na-upload itong example number 5. And then submission on Friday again. Ha? Once again.
Okay, ma'am.
Question. May natutunan ba? O lalong nalito?
Meron naman, ma'am.
Okay, sige.
Meron naman po, ma'am.
Okay.
Kung
Sino yung mga wala kanina? Si Jubel Dome, andito na?
Yes, ma'am.
Dito ka na? Okay, Marquez. Jubel, lalaki ka ba babae?
Lalaki, ma'am.
Patingin nga. Jubel,
Ano yung boses?
ikaw ba yung EMT? Ay, ano ba? Ano ba ang ano mo, tech mo? Christopher Ferrer, andyan ka na ba? Christopher Ferrer? Wala pa rin? Absent? Absent? Okay, Christopher Ferrer. Wala talaga.
Tapos may pangalan mo.
Mary Joy Estado.
Present.
Okay, present. Sino pa ba? Mary Jean Martinez.
Kasi magpapasa mo naman ay pangalan na yun.
Martinez.
Lagay mo na rin
Absent.
sa papalamitin. Morgado para
Rodaline Santillan. Rodaline Santillan. And David Tan. Rodaline Santillan, are you here?
basta souvenir sa lugar.
Wala. David Tan.
Present, ma'am. Present po.
Present. Sino ka? Sino ka naka-raise hand? Wait lang. Santillan. Okay. Walang ano.
Yung volcano, gano'n.
Hindi ako.
Naka-off mic ka.
Sa Laguna lang.
Okay na. Ang absent ay verify ko lang ha. Christopher Ferrer.
Bakit madami yan?
Mary Jean Martinez. Ayan. Dalawa. Dalawa, no? Okay. So, that's all. Okay. So, I hope may natutunan kayo. So, that's it. No more question?
Ito, hindi mo Laguna yan. Ito.
No more question?
Wala po, ma'am.
So,
Wala po, ma'am.
Tama ko.
class
Wala po.
Okay na.
Kuya mo.
Okay. Okay. This class is you're officially dismissed. So I'll stop the recording now. So bye.